Hi students, welcome to Curie Electronics. Today I am starting a new series, Straight Theory Electronics complete lecture series. Most of you have done your 10th and PUC. After that you might have joined for ITI. So I will try to keep the lecture duration to maximum 30 minutes, that is half an hour, not more than that. But this video series will be useful for you to prepare for your competitive exams as well as your board exams. So this is the first lecture. Today we'll just see what is electricity, resistance, specific resistance, temperature, coefficient, first terms. So we'll start. So I'll be referring AK Mittal. So AK Mittal is the book, Basic Electronics of AK Mittal. This is the book I am going to refer. So any question, please feel to ask the comment section. So if any of you are preparing for exams, definitely watch the lectures completely. So we will start. This is our first lecture. All the best for you, all of you. Thank you. Thank you for what to watch the lecture and understand things thoroughly and become good technicians, and future you'll become good engineers. So we'll start. So what is electricity? The first term for an electronics mechanic, the first term will come across is electricity. Electricity. What is electricity? Electric. What is electricity? The first term will come out. Or what is electric current? Or what is electric current? What is electric current? I think all of you might have seen in the cells. We call it as battery. Actually, it is a cell, single cell. We call it as a battery. Now, we'll take a battery. So plus, it's a battery. It's a plus, and we have a conductor here. This let it be a wire or whatever it is, or a resistor, or a okay. This is a wire. Now we will connect a 1.5 volt battery here. So what happens? See, the things you have to understand is that battery doesn't provide electrons. Okay, if you see this battery doesn't provide electrons. Battery doesn't provide electrons. Then from where this electrons comes? It comes from the conductor. Okay, the electrons come from the conductor. That means this conductor will have many electrons. Many electrons will be there. So when you connect plus here, the battery will provide a potential difference. So what happens? All the electrons will move from there to here. So when you connect like this, what happens? The electrons will move from here to the battery, and through battery mechanism, it goes here. Through battery mechanism, it goes here. Just to simplify the things, we'll say battery mechanism. Battery mechanism. Because for the current to flow, the circuit has to be closed. Circuit has to be closed for current flow. Current, current flow. Okay, now let the initial lecture, the first time you are learning, so you just understand that when you connect a battery, the electrons moves. See the electrons moving from the negative terminal to the positive terminal of the battery. So the conventional current flow, there is that is opposite to the, we will say, current flow. Current flow will be like this, in this direction. It will be going like this. That is the conventional current flow. Conventional current flow. Conventional current flow. Okay, so this is just a basic idea. I will with this will be clear later on after after around 5 lectures. You will be thorough about it. Okay, now we'll just write what is the definition for electric current. What is the definition for electric current? Try to learn with me so that you need not learn anything later. The flow, the flow of electrons or charges through a conductor is known as electric current. That is what electric current. When you hear the word electric current, it means that electrons are moving through a conductor. That's it. Okay. Now if you see, there are two types of electric current. Okay, there are two types of electric current. That is, see, whatever the current, whatever at home, whatever the current we uses, that is AC, that is alternating current. Alternating current or AC. What is the home? What is the supply? That is 230 volt, 50 hertz. 50 hertz is the alternating current frequency, whatever we use in India. Just for information. Later on, we will be come across these AC DC terms. Now, one more type battery is there. One more type of current is there. That is direct current. Whatever we have seen, the current through the battery, that is direct current. Direct current or DC. And if you have a graph like this time and voltage, DC will have a same value. This is DC. DC value doesn't vary. It will be same value DC. But the same if you draw for AC, what happens? AC every instant is a voltage and time. This is for AC. If you draw a plot, each and every instant the value will be changing. This is what AC. Okay. Now this is just to start the things. Now we know that some idea about current, what it is. Now an important component is there, that is a resistance. Now, so wherever the current flows, their current resistance is there. Now we are learning the resistance law. Okay, the first topic we are learning today is resistance law. Resistance law. I won't be writing all definitions. Okay, resistance law. Now we have a conductor. We have a conductor. Assume a wire itself. Its length is L. area equal to A, then resistance of the conductor, resistance of the conductor R, that is R. The resistance is represented by R. R equals R is directly proportional to this resistance of the conductor will be directly proportional to the length of the conductor divided by area of the conductor. So this is a proportional. This is a proportional. So there will be proportionality coefficient. Now we'll put the proportionality coefficient, that is R equals rho L by A. Now here R equal to resistance. Here it is resistance of the conductor. And what is L? L already we wrote. Now what is the rho? Specific resistance. Specific resistance of the material, of the wire in this case. Okay. So this is the equation for resistance. Whenever you have conductor, resistance equal to rho L by A. R equal to rho. Specific resistivity also we call it rho L divided by A. Now this is the resistance. Once you know, we can find the now the units. L if you take it in centimeter, A also you should take it in centimeter. Usually we will go with centimeter only. Why? Because specific resistance normally comes in ohm centimeter. Ohm centimeter. We will solve one simple problem. Then you will get it. And the resistivity of some materials, it is better to know some resistivity of some of the materials. Okay. So for copper, rho equal to 1.7 multiplied by 10 to the power minus 6 ohm centimeter. Similarly for silver rho equal to 1.64 multiplied by 10 to the power minus 6 ohm centimeter. You should have an idea what is the value could come. Okay, so at least these two you should know. There is one more question. Okay, before going that, we will solve one simple numeric. One simple question. Calculate the resistance. Calculate the resistance Okay, instead of writing the question completely, it may take more time. So I will just tell the question what it is and we'll solve it. Okay. Now this is this length. This is a conductor. Length equal to, it's a conductor. Okay, now I'll write it down. L equal to, length of the conductor is 2 kilometer. 2 kilometer. And area is given as 5 millimeter square, 5 mm square. And a rho of copper. What is the resistivity or specific resistance of the copper? This is a copper material. Okay, that's a 1.7 into 10 to the power minus 6 ohm centimeter. Ohm centimeter. So this is the data given. We have to find the resistance. We have to find R equal to question. The resistance we have to find. Okay. Now R equal to, what is the resistance equation? Rho multiplied by length by area. If we see in this equation, resistance is directly proportional to L and resistance is inversely proportional to 1 by A. Okay. Okay, now we'll put the values. R equal to rho value. What is the rho value? 1.7 multiplied by 10 to the power minus 6. What is the L? L is given us 2 kilometer. Actually, we need it in centimeter because our specific resistance is in centimeter. So what we'll do? First, you will convert kilometer to meter. If you multiply by 1000 kilometer, it will become 2000 meters. But again, we need it in centimeter. Again, we need it in centimeter. So 1 meter equal to 100 centimeter. So we will get 2 multiplied by 10 to the power. How many zeros are there? 5 zeros. 10 multiplied 5. So this is the first lecture. So let me see how the timing it, how long it will take. Anyway, I think maximum half an hour, not more than that. I'm not going. Okay, so we'll try to just be start with. We'll try to get rolling. Okay. So now, okay, divided by what is the numerator? What is their area? Area he has given us 5 mm square. We want to convert it into meter square. That is 10. If you multiply it by 10 to the power minus 2, it will convert to centimeter square. Okay, now all unit we have taken care. Now we'll multiply. This 10 to the power minus 6 into 10 to the power 5 will give 1 by 10. 1 by 10. 1 by 10. So that is 1.7 multiplied by 10 to the power minus 1 we will be left with, multiplied by 2 upon 5 multiplied by 10 to the power minus 2. So now if you multiply, what we get? 1.7 into 2. 1.7 multiplied by 2. I forgot to take the calculator. Okay, 1.7 1734. So it will come 3.4 3.4 into 10 to the power minus 1. 5 into 10 to the power minus 2. So this minus 2 minus 1 and minus 2 cancels here. You will get 10 to the power minus 1 here. That is 3.4 divided by 0.5. If we divide, what we get? 3.4 3.4 divided by 0.5. We'll get 6.8 ohms. So the answer for this is 6.8 ohms. We got 6.8 ohms. So this is how you will calculate the resistance of a conductor. So guys, we'll stop it here today. So this is the first lecture. So like this, I'll be going through each topic and each and everything required for the electronic mechanics third theory. So how many lectures I don't know, but you will get the complete content free of cost. So thanks for watching. Thank you.